to record that one. Again, let's try another word problem. Okay, word problems here. This one is going to have something to do with actually like going to the grocery store, going to the liquor store, wherever you go, corner store, and buying things. Okay, so let's first write our equations. So we're on example number 5. Okay, so we're dealing with packs of gum, candy bars, and bags of chips. Now, be careful because C could stand for candy bar or for chips. So you make sure that you define your variables. So I'm going to use G for gum. I'm going to use CB for candy bar. And CH for chips. Okay, just be careful that you don't use C for both. Okay, so make sure you define your variables somewhere. Okay, so one shopper bought 2 packs of gum, so 2G, plus 3 candy bars, 3 CB, plus 1 CH, for $3.07. A second shopper purchasing the same brands paid $3.79 for 3 Gs plus 2 candy bars plus 2 chips, and they paid $3.79. A third person bought 4 packs of gum plus 4 candy bars plus 3 bags of chips for $6.01. We want to find the cost of each individual item. So, you have set up a systems of equations, right? And now we need to solve it. Okay, so we want to figure out, do you want to use addition method or substitution? Probably addition method, because it's generally a little bit easier. Okay, so what do you want to cancel out? Do you want to cancel out gum, candy bars, or chips? Probably chips, because that's the only one that has a coefficient of 1. You don't have to do that, but I believe that would be the easiest way. Okay, so you're going to pick 2 different equations to eliminate things from. So we have equation 1, 2, and 3. Okay, let's just start with 1 and 2. So I'm going to eliminate chips from equation 1 and equation 2. Okay, so 2G plus 3CB plus 1 chips equals 307. Now, can you just get rid of these decimal places? No, you cannot. Okay, and the reason you can't just get rid of the decimal places is because there's only a decimal on one side. So if you moved these decimals over, you would have to add in decimals on the other side, and you would get really big numbers. So just leave it, okay? It's not going to be that bad. Now, I want to eliminate chips, so I can multiply my first equation by -2. You multiply that through, that gives you -4G minus 6CB minus 2CH equals -614. Rewrite your second equation underneath. So 3G plus 2CB plus 2CH equals 379. Add those together, the chips cancel out. We get -1G minus 4 candy bars equals -235. So I have one equation where I've eliminated the chips. Now again, we're going to eliminate chips, but we're going to use different equations. So you could use 1 and 3 or 2 and 3. Since this one has a coefficient of 1, I'm going to use that one because it's probably a little bit easier. So I'm going to use equation 1. I have to use a different one this time, so use equation 3. So if you rewrite those, we have 2 gum plus 3 candy bars plus 1 chips equals 307. Your third equation was 4 gum plus 4 candy bars plus 3 chips equals 601. Now, even though the G's look like it would be easy to just multiply by -2 on this first one, remember, we need to cancel out the same variable from a couple of equations. So here, we have to do the chips. So multiply everything else through by -3. Multiply by -3, that gives you -6G minus 9CB minus 3CH equals 921, negative 921. Rewrite your second equation, 4G plus 4CB plus 3CH equals 601. Add together your equations and the chips cancel out. We got negative 2G minus 5CB equals negative $3.20. Take your two newly formed equations and line them up. So negative 1G minus 4 candy bars equals negative 235. Negative 2 gum minus 5CB equals negative 320. And now I want to use these equations and cancel out a variable. What variable would probably be easiest to cancel out? The G's. Okay, so multiply the top one by a negative 2. So you'll have one positive, one negative. When I rewrite those, write it down here. We got 2G plus 8CB equals 470. Your second equation, just rewrite it, negative 2G minus 5CB equals negative 320. Add these together, the G's cancel. 3 candy bars equals 150. Now, especially if you took out the decimals earlier, this would not make any sense, okay? You would get candy bars equals 0.50. If you took out the decimal places and you got 50, you're saying that a candy bar is $50. That doesn't make any sense, okay? So your candy bar is 50 cents. So I have one equation, or one variable solved for. Now take this, and we're going to plug into other equations to find the rest of the variables. So you can do any of the equations. I'll use this one. These are really long problems, yes. They do end eventually, but yes, this is the last one. Okay. So 8 times 50 cents equals 470. Technically, I have more for the B lecture, but we're not going to do that because I just don't want to talk anymore. So plus $4 equals 470. You subtract $4 from both sides. Subtract $4, we get 2 packs of gum for 70 cents. Divide by 2 on both sides. And gum is 35 cents. Now, take these, plug into one of the original equations, and we'll figure out what the last thing equals. I'm going to use equation 1. You can use any of them though, okay? And that was 2 gum, 3 candy bars, plus 1 bag of chips was 307. So if you plug in 2 times 35 cents plus 3 times 50 cents plus 1 bag of chips is 307. 70 cents plus $1.50 and 1 bag of chips is 307. Add those together, $2.20 plus 1 bag of chips is 307. Subtract 220. We're almost done. 1 bag of chips is 87 cents. And you're done. Yay.